In this video I talk about functions. Let's have a quick look at the help for the concept of a function. Now a function, like in script, is an M file, a file with extension .m that contains a sequence of executable statements, operations, or call to other functions. The crucial difference to a script is that each function has its own workspace, which is not visible from outside, and if you are in the function in the course of the execution, you cannot see the workspace of the calling script or the calling function. This means that the variables in a function are all local variables, with certain exceptions. We'll see later that we can define also global variables, which are visible in all workspaces where they are defined, but this is not a recommended procedure. So let's start with a very simple example. I use the file example simple function. The first line starts with the declaration function, and the rest of the first line defines the calling syntax of this function. It has the form output argument or list of output arguments equals the function name, and then in brackets there are the input arguments, then there's a sequence of operations, and we terminate the function by the keyword end. Now let's put a breakpoint at line 2, and let's call this function from the command window. So I define, let's clear the workspace first. So I define a equals 3 and b equals -2. And now I call the function without an output argument. So I just simply type example simple function of a and b. That was a typo. Okay, now we're inside the function. Let's look at the workspace. So what do we see in memory? Well, at the current point in time, we only see the input arguments, which are x and y. X has the value we have assigned to a, and y has the value we have assigned to b. Now we operate on these two variables and compute z. Z equals 13, and then we leave the function and we are back to the command window. Since I have not specified an output argument, the output will be stored in the variable ans, answer. Of course, I can also store the output in a different variable. I just have to specify, for instance, c equals the output of this function, and now let's step out of the function c equals 13. So when we're inside the function, we don't see the base workspace, and if you're outside the function, we do not see into the workspace of the function. So the variable z is not defined in our base workspace. It's only defined after it's computed inside the function that we see in the editor. Now that's a really very simple function. So let's look at a slightly more complex example. Let's look at the file example vectorized function. Many functions in Matlab and also in the toolboxes are vectorized, which means they take vector or matrix or array arguments. In fact, the interface of this function looks entirely the same as the one of the preceding example, But now we have to deal with the case that x and y are vectors, matrices, arrays. In order to work, to be able to compute this command, we have to make sure that x and y are of the same size. So if I call this function from the workspace, let's define two vectors, a equals, let's use row vectors, 1, 6, and the same for b. And then now let me call this function with output argument c. Okay, so we stop at line 2, and now I check that all dimensions of x and y are actually the same. So size is a vector which gives the dimension of the array x, and I request with the function all that all elements of these two vectors are identical. In this case, we can safely execute this command. Otherwise, I throw an error and display this error message. I terminate this function by the keyword "and". This is not strictly necessary in this case, so I could also put in a return statement. But just to be sure, I terminate all functions with the keyword "and". Okay, and now we display the result c, which is a vector computed according to this prescription. Now let's look at a more complicated example where I can show you how to deal with a variable number of arguments, input arguments, variable number of output arguments. So there's a lot of flexibility in defining the interface, so you can call a function with a different number of input arguments, and you can ask for a different number of output arguments. Okay, so let's now try to execute this script. This is a script. The function that I want to show you is appended in the M file of the script after the end of the script. This is called a local function or a subfunction, and this function can be called only from this script. What's the reason for this? Well, if you define a function, the function is defined by its file name, not by the function name. It's good practice to give the same name to the function as to the file name, but it's not obligatory. You don't have to do it, but I would recommend to do it. Now, this function is inside a script which is called example function. So this function is invisible from outside the script. You cannot call it from the workspace, for instance, because it's not identified by a file name. The file name is the name of the script, not of the function. So if you want a function to be visible from the workspace, from everywhere on the search path, it has to be in its own file. And the calling name is defined by the file name, not the function name. Okay, so let's now run this script. Okay, the usual preliminaries. I set the random number generator and I create a random vector. And the function is called myFun, and it has the following syntax, calling syntax. We have a list of output arguments. This one is always computed, and these are optional outputs. This is an obligatory input. You have to give the function something like x, and then you can add a variable number of other input arguments. Now, var argout and var argin, so variable arguments out, variable arguments in, these are cell arrays. And when you enter the function at line 44, this is the first executable statement, you can ask for the number of input arguments in this cell array and the number of required output arguments in this cell array by two functions which are called nargin, number of arguments in, and nargout, number of arguments out. So this tells you which input arguments, how many input arguments you can use and how many output arguments you have to provide. Now I will call this function with different lists of inputs and different lists of output. So what does a function do? Well, if in any case we have to pass the argument x to the function, and then it computes simply the mean of this vector. So it assumes that this is a vector or a matrix, and it returns the mean, arithmetical mean in the case of a vector, or the column means in case of a matrix. So this has to be computed because this is not an optional argument, it's obligatory. Now, if nargin is greater than 1, so we have something in this cell array. Now we have to find out what is the length of this cell array and what is in it. So if nargin is greater than 1, then I extract the contents of this cell array. I compute the length of the cell array, which tells me the number of additional arguments, and then I make a computation. So you can recognize that here I compute a higher moment of the vector x, and I do this for every exponent in the cell array var argin. Okay, and these are then stored in the corresponding elements of var argout. So I fill now this array of optional output arguments by this computation, and then I return from the function and I close the function with the keyword end. Okay, now let's see what happens if we make these calls with different calling sequences. You may have noticed that many functions, the toolboxes, have a large number of possible interfaces, and depending on which arguments you pass to the function, it has a different functionality. A typical example would be, let's say, let me quit this for a moment. If you define a matrix A, round 7, well, that's too big, round 5, there's a function mean of A, which computes the column means. You can also type mean A2. This computes the row means and returns a column vector. You can also type A1, which is the same as mean A. So this displays the row vector of the column means. Okay, this is a typical example according to how many arguments to pass to the function. It does different things. And this I want to demonstrate now by this Example script, let's start again. So I have a loop. The possible input here is 1 to 7 or 0 to stop. And these calling types correspond to different ways of calling this function myFun. So let's start with 1. So we're now inside the function. I have called with a single input argument, and I have not requested an output argument. So let's have a look at the number of input arguments. We have one input argument and no output argument. This is returned by the functions nargin and nargout. Now we have, of course, the input argument x. This is this vector. We compute the mean value. Now we have only one input argument, so this is false, so we'll skip. And we return from the function. Okay. And now, since I have not specified an output argument, the result is in the variable ans answer. Okay, let's go on. Let's try calling type 2. Now, what is calling type 2? In this case, I call with one input and one output argument. Let's go down to the function. I again compute the average. We have still only one input argument, so this is now what the function returns, and it's stored in the variable mom1, first moment. Okay, so let's try calling type 3. So what is calling type 3? Now 3 is a call with one input argument and two output arguments. Now what happens in this case? Well, we have now one input argument, two output arguments. We compute the average. We have still only one input argument. So we immediately return, but we have asked for two output arguments and only one, the first one, is computed. So this is wrong. We have asked for an output argument which is not computed, so we are in the catch block and we display an error message and we continue. Okay, let's try calling type 4. So what is calling type 4? Well, that's the same actually, so we go immediately to 5. Now what is calling type 5? I call with two output arguments and one input argument, which means I also want the second moment. So let's see how that works. We have now two inputs, two output arguments. We compute the obligatory output, the average, and now we have an additional input argument. There's just one. That's the length of this cell array var argin. We extract the exponent from the cell array and we compute the corresponding output argument, the corresponding cell in this cell array. and we return. And now we have two outputs, first moment and second moment. We can do the same with 3 input arguments and 3 output arguments. So this is case 6. This is just like before. We have now 2 exponents in this cell array var argin, and we compute the second and the third moment of the vector x. We return, and we have now filled 3 output arguments, mom1, mom2, and mom3. Okay, and finally we call with type 7, and this means we are not interested in the average, we're just interested in the second and third moment, so the obligatory output argument will not be returned. In order to achieve this, we put a tilde in place of the argument, which is of course computed inside the function but not returned to the calling script. So let's step through this. We have now 2 additional arguments in this cell array. We have computed the average, but the average is not returned because we have not requested it from the calling script. So just mom2 and mom3 are returned, and the first argument is missing. Okay, that's it. Let's stop this script and let's go now to the next example, which